Hello everyone. Here I am going to discuss about the topic process scheduling in operating system. Okay. First of all, we know that the main aim of multiprogramming is to maximize the CPU utilization, that is, to reduce the ideal time of CPU. In the case of multiprogramming, the RAM keeps the multiple program so that there is always a program will present for the execute the CPU. That is, the main objective of multiprogramming is to maximize the CPU utilization. And in the case of time sharing system, it will provide a quick response, that is, which allocate a particular time for performing each process. So when the time over, the CPU will automatically switch to the next process and so on. That is, we get a quick response. And suppose there exists a single process system, and there is so many processes await for their execution, but the process can only process one process at a time, and the method of selecting a process for execution is called as scheduling. And now we discuss about the some scheduling queues. And in the case of scheduling, there are some important terms. That is, first one is job queue, and second one is ready queue, and the third one is device queue. And here the queue is already we studied in the data structure, and the queue is actually a FIFO structure, that is first in first out. And here the job queue is present in the hard disk, and whatever we install in our system, which will permanently store in the hard disk. So this data is stored at the job queue. That is, the job queue is a space in the secondary storage. Then next we can discuss about the ready queue. That is, the ready queue is the queue in the main memory. The main memory means that it is the RAM, and this is the process. That is, the process are waiting in RAM as a queue. For the execution, we took process from the RAM, and the ready queue is implemented as the linked list form. That is, the queue is generally stored as the linked list form. Then next one is the device queue. In our system, the most of the devices are stored as the shared devices. That is, a system has many processes. One of its requests for a disk. One of it requests for a disk, and but the disk may be busy with the I/O request of some other process, so that the other process will wait for the disk, and the list of the process will waiting for a particular I/O device is called as the device queue. That is, each device is its own device queue. And the figure shows that the ready queue and the various I/O devices queue. Here is the head of the queue, and he has a head and a tail. And in ready queue, that is, it is the ready queue, and the ready queue there is two processes are waiting. That is the process PCB7 and PCB2. And PCB is the process control block, and PCB7, that is, which is the seventh process, and each processor identified using the process number. And also there is a PCB2 is present, that is the second process. The next one is the device queue, that is which is represented as the magnetic tape. That is, there is no processes waiting. And the next one is also a device queue, and that is represented as a magnetic tape, and there is no process will waiting. And the next one is the disk unit 0, and here there is three processes are waiting, that is PCB3, PCB14 and PCB6. Okay. Then the head of the disk unit is pointing to the PCB, and the tail is pointing to the last process in this disk unit. And in the case of ready queue, the tail is pointing to the last process, and the process are waiting in the linked list fashion. That is, the each process are waiting in the linked list fashion. The terminal unit, the terminal unit also has a one process in waiting, and the head and tail is pointing to the PCB. And here the first one is the ready queue, and the others are the IO device queue. Then we can discuss about the topic, the queue diagram. Queue diagram is used to representing the process scheduling. Here the figure shows that there is a ready queue is present at the RAM, and the processor waiting as the ready queue in RAM. That is, the CPU take the process from ready queue, and suppose a CPU take the process from ready queue and it start the execution, and then if there is any IO request is occur, then it will go to the IO waiting queue, and after when the IO request is completed, it will go to the ready queue. And if the exists a time slice is expired, then expired due to the expired when the execution process is occur, then the process is directly go to the ready queue. And if there is a child is created while executing the process, that is the a fork child. That is, fork is a system call. While using the system call, the process create a new process or a new child. A new created process known as the child process, and the parent process will wait. The child process will wait, and the parent process will wait, and the child process is executed. And after the execution of the child process, the parent process will go to the ready state. And the when there is an interrupt is occur, then it will directly go to the ready queue. And this is the figure showing the queuing diagram. And the figure shows that how the CPU switches from one process to another process. That is, there is two processes are present in, that is P0 and P1 are the process. The process P0 is currently executing, and there is an interrupt or a system call is occur. Then the current process, the process of execution is saved to the PCB 0. Then the PCB is the process control block, and the PCB 0 means that the process control block is at the P0 process. The PCB is used for representing the process operating system. Then it is reloaded to the state PCB1, and the process P1 is become executed, and the in the execution time, if there is an interrupt or a system call is arise, and it will save to the PCB1, and then it reloaded the process P0. Then previously the P0 is in the ideal state, and now it will become continue the execution. Then next we already discussed about the scheduling, and there is a scheduling as a method of selecting a process for execution. In the system programmer, the jobs are presented in the job pool. The job pool is the area in the hard disk. The queue, the queue in the job pool is also known as the job queue. The job queue, in the job queue, the programmers are waiting for the allocation of main memory, and the selection process also carried by the appropriate scheduler. And there are different type of scheduler. Here we discuss about the three types of scheduler. The first one is long-term scheduler. In the long-term scheduler, it is the job scheduler. That is, the long-term scheduler is otherwise called as the job scheduler. That is, it selects the process from job pool and it loads them to the memory for execution. And the next one is short-term scheduler, and it is the CPU scheduler that it selects the process from main memory and it allocates the CPU for execution of the job. And in case of short and long term scheduler, the short term scheduler is more frequent. That is, when the CPU select a process and that process must have an IO operation, so the CPU must select the next process quickly. The process is assigned to the CPU from the short term scheduler, so it is the frequent scheduler. And in the long term scheduler, the control this long term scheduler is the which control the degree of multi-programming, that is the number of processes in the memory is controlled by the long term scheduler. That the long term scheduler may need to be invoked only when a process leaves the system. Then there are two types of schedulers processes are available, that is IO bound process and CPU bound process. The IO bound process spend more time for doing IO than spend doing the computation. Then the CPU bound process using more time doing computation than the IO bound process done. That is, the long term scheduler should make the IO and CPU bound process. The system with the best performance will have the combination of CPU and IO bound process. Then the next scheduler is midterm scheduler. The midterm scheduler is only possible in the Unix operating system. That is, there is no long-term scheduler is available. The execution of midterm scheduler is done using this figure. That is, in this figure, there is a ready queue is presented, and it is the ready queue for executing a process, and it schedules a process to CPU. And when an execution is started, if there exists an IO operation, then the process goes to the IO waiting queue, and after completing the IO operation, it will go to the ready queue. In some case, the process are swap out to any other memory area. That is, here the way the processes start out to the any memory area. That is, when a process is run and it want more memory from RAM, and then it want to temporarily replace the space from the RAM, and so it is used to swap out the process, and the running process swap out, and it is placed to the swapped area, and after the execution it will come out to the swap in come out in swapping state, and will go to the ready queue. And that is the main function of medium term scheduler is perform swapping and swap out operation. Okay, that's all about the process scheduler. Thank you.